Hey, my champions, I Abhinav Negi welcome you all on BYJU'S exam prep. So this is the startup series, and today in geotechnical engineering, we will be doing the grain size distribution. Before I start this topic, let me tell you guys that today the BARC result has been announced. Around 217, I guess 213 or 217 students in civil engineering. 213 and 217, I guess civil engineering students are selected. Okay, 217 I guess, and they will be now selecting their interview dates, because yes, after selecting in the exam, you can book your slots for interview. There are various dates of interview. You can book any on the first come first basis services, and the written marks will not be counted. The gate score, if you are selected from gate score will not be counted. If you are selected from written exam, that will not be counted, and directly your interview will be the final criteria for your selection. Interview here is entirely different from PSU, entirely different from MTech interviews, entirely different from engineering services, because here and not at all they will look for your personality. They will not look for your leadership quality. Only one thing, one and only one thing, that is your technical thing. Okay, so tomorrow 7 p.m. I will be coming live again for the complete interview guidance program for BARC examination. Okay, those who are new here, though not knowing me, let me introduce myself. My name is Abhinav Negi, having 11 plus years of teaching experience and my MTech from IIT Delhi in geotechnical engineering. Got All India rank 164 in 2012. This is my mail ID, and you can join me in my Telegram group, Civil by Abhinav sir also. So this we have already done. I got a huge response from you guys here in this session. Then this is the second, and this I will be taking on Saturday 6:30 p.m. on complete soil classification. To study about the soil classification, you should be knowing about the grain size distribution. That is why I have taken this topic first, and after grain size distribution on Saturday 6:30 p.m. we'll be doing this. Now this will be tomorrow guys at 7 p.m. Tomorrow 7 p.m. on YouTube, the complete BARC interview guidance session. I hope you all will be coming here and getting benefited. Okay, so this time Sunday ka funda, I'll be coming with a very special video. You can see that at this Sunday. Okay, Telegram group Civil by Abhinav sir. Shall we start, everybody? Can you please let me know in the comment box, are you all ready? Okay, everybody, come on. Ready हैं क्या भाई सब लोग? Okay, सब ready हैं? Okay, so shall we start then in that case? Okay, चलो भाई लोग स्टार्ट करते हैं, ठीक है? चलिए सुनो, ग्रेन साइज डिस्ट्रीब्यूशन कर्व पढ़ाने से पहले, बिफोर आई टीच यू ग्रेन साइज डिस्ट्रीब्यूशन, लेट मी टेल यू व्हाट इज इंडेक्स प्रॉपर्टीज. Because grain size distribution is directly related to this. So pehle let us understand the base, that what is the base, why we are studying grain size distribution, what are its benefit. ऐसे थोड़ी नहीं ऐसे ही पढ़ दिया टॉपिक यार. क्यों ग्रेन साइज डिस्ट्रीब्यूशन कर्व बना, क्यों ग्रेन साइज डिस्ट्रीब्यूशन पढ़ते हैं? क्योंकि गेट में एक क्वेश्चन देना है जबरदस्ती का, तो जबरदस्ती एक टॉपिक पढ़ लेते हैं, नहीं ना. उस आप ट्रिग्नोमेट्री पढ़ते हो क्योंकि उसका कुछ यूज होता है लाइफ में. बहुत सारे कॉमर्स के बच्चे या कुछ साइंस के बच्चे भी बाद में कहते हैं, तो साइन थीटा पढ़ा था क्या फ़ायदा हुआ, कॉस थीटा पढ़ा था क्या फ़ायदा हुआ, है ना, टैन थीटा पढ़ा था क्या फ़ायदा हुआ. बहुत सारी चीज़ें आप ऐसे कुछ बच्चे पूछते हैं, ठीक है. तो ऐसे बचपन में मैंने कंघी बनाना सीखा था, मैं कंघी नहीं बनाता हूँ, हाथ ऐसे करता हूँ बस, तो क्या फ़ायदा हुआ ऐसे, ठीक है. तो आप जब स्कूल लेवल पे होते हैं, आपको नहीं पता कि आप कैरियर के किस पाथ पर आगे जाएंगे. Many students goes in a particular path for finding out the heights of the tall building, the elevation of the mountains, or in fact rivers also. In all these things, trigonometry is used directly, and indirectly it is used in infinite ways for infinite things. Okay, so guys, everything has a relevance. Then only that is the reason why we are studying that. Na, unnecessary topics are not there. Similarly, grain size distribution is also, we are studying for finding out the properties. What are these properties? Let us study now. So what are the index properties? Index properties are those properties these are those properties which helps us to find out the engineering behavior of soil, okay. Now index properties are also engineering behavior means its settlement, its strength and its consolidation, everything. Now index properties are also again two type. One is aggregate property, and one is grain property. Aggregate property means that depends on the whole skeleton, like void ratio. Void ratio does not depend on a single particle. Void ratio depends on the whole skeleton. Okay. So like density is not depending on the whole soil structure on a single particle. It depends on the volume occupied, or the ratio, or the percentage, or the fraction occupied by the voids, by the water, by the air voids, by the solid particles. So all these properties where the whole skeleton is important, with only one grain, we cannot do anything. The whole skeleton is important. That is called as soil aggregate property. And soil grain property means only one particle is required. Only one particle is required. The whole particle is not required. Okay. Now it is very obvious. It is quite obvious that if we want soil grain property, then in that case we can go for the disturbed sample also. Because even if you disturb this, even if we break this structure, then in that case also the single grain, as we considered solids to be incompressible, is not changing. So we can go for disturbed sample also. But when the whole aggregate is making some property, then in that case undisturbed sample is required. Either you take out the undisturbed sample so these voids are not changing, or you do the testing in the field itself. भाई इस लैब तक लाओ मत, नहीं तो डिस्टर्ब हो जाएगा. तो वेरी ऑब्वियस है यार, जहां पे ग्रेन प्रॉपर्टी है उसका कैसा भी गटर कर लो, it will help. But when the whole skeleton is important, then either you take the undisturbed sample or you do the in situ testing, in field testing. Now guys, moving forward, for coarse grain soils, the grain size distribution is very important. I always say for coarse grain soil, its relation is that grain size distribution. Why I told you yesterday or day before yesterday also in the phase diagram. Why grain size distribution is very important, I told you in day before yesterday also, that I want that for a particular soil skeleton, the large particles are also there, XL particles are also there, the medium particles are also there, okay, the small particles are also there, so that the small voids are filled with small particles. So I'm very happy to see these kind of soil. When XL, double XL, L, M, small, all particles are there. I'm very happy to see this. Okay. So coarse grain soil, this is very important. For fine grain soil, I told you yesterday also, day before yesterday also, this is not very important. Because for fine grain soil, I'm saying, oh my God, very beautiful soil. Okay. For these kind of soil are very poor, na. Uniformly graded soil, when all particles are of almost same size. This is uniformly soil or poor soil. Uniform size represents poor in soil mechanics because small particles are not present to fill the voids. But for fine grain soil, we cannot say this. It might be in fine grain soil, the voids are there, but due to cohesion, they have a strong bonding, strong strength. So for fine grain soil, this grain size distribution is not important property. Because for fine grain soil, if you say this poor, but might be due to cohesion, they are strongly attracted and having a strong bond and having a strong strength. So दूर से देखा तो गंजे खेल रहे थे, पास जाके देखा तो अंडे उबल रहे थे. From very far away for fine grain soil you say it poor, but when you go near you see it is very good, yeah, due to cohesion. So grain size distribution, that all particles should be of different size, it should not be of same size, is relatable to coarse grain soil. For fine grain soil we cannot say this. For fine grain soil the index properties are water content, liquid limit, plastic limit and shrinkage limit. What is that? We will see in another video, yaar. Because fine grain soil, I told you, the water is very important property. Water के साथ खेलते हैं वो, and with a slight change in water content, properties changes drastically. Okay. Suppose this is a flaky shape, because fine grain soil is flaky shape having charge distribution. So water is a dipole. So H plus may attract like this, or it may be some cation, K plus, calcium plus, and then OH minus is attracted to this. So water dipole is खेलता है इसके साथ. Okay, excellent. Now we are going to find out now grain size distribution curve, and we want these kind of particles. We want these kind of particles, not this one. Okay, we want these kind of particles, not this one. Got it? Got it? Okay. Now grain size distribution, what we do, please see here, that we take 1000 gram of soil. Okay, we take 1000 gram of, बड़ा नहीं हो रहा, leave it like this also, leave it like this. So we take 1000 gram of soil, we put here. There are different sieves. Okay, the bigger diameter sieve is at the top. The bigger diameter sieve is at the top. The sizes are bigger, then smaller, and then further smaller. So of course when we put 1000 gram of soil, we shake it, either we shake it mechanically or we shake it with motors. Okay, so in that case, after shaking of 10 to 15 minutes, we take different sieves, and taking different sieves and weighing them. Shake for 10 minutes either mechanically or manually, take the different size, which are bigger particles that are retained here, medium particle retained here, smaller particles are retained here, and we weight the different size. Okay, now there are in total 11 sieves. Larger sieve at the top, then here larger particles will be retained here, then smaller, then very small particles are retained here. Now let me tell you one more thing here, that this is irrelevant for fine grain soil. For fine grain soil, this is irrelevant. The sieve analysis is irrelevant. First thing, कि fine grain soil के लिए this grain size distribution is not very important thing. If all particles are of same size, we cannot say it poor. So first thing is that for fine grain soil, this is not very important. Second thing, even if you want, समय नहीं कट रहा है घर में, समय नहीं कट रहा है घर में. Even if you want it, then in that case also, even if you want, then also sieve is not the suitable criteria, because fine grain soil has cohesion. Small particles may attract each other and they becomes flock. Small particles, one small particles make a flock, and that is retaining here. Actually that particle's size is similar around here, but that will retain here due to making of guchha, due to making of flock. And we are thinking, oh, this is a bigger particle, this much 20 gram is bigger particle, but actually it is small. So sieve analysis is not even a good thing for finding out the size distribution for fine grain soil. So actually there are total 11 sieves, 80 mm, 20 mm like this, and like this. There are 425. This is mm. So there are total 11 sieves, 4 at top, then 7 at the bottom. Now suppose we have taken 1000 gram of soil, and there are 11 sieves like these. There are 11 sieves, and for 11 sieves, after shaking of 10 minutes, after shaking for 10 minutes, what we got the result, that is written here. Now how to find grain size distribution, that I am taking. Hello Arun, थोड़ा लेट हो गया यार आज, कैसे हो? Hello Arun, कैसे हो? Okay, now everyone please see here. So on 11 sieves, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then pen at the bottom. This micrometer, we get this much. Okay, so if you do cumulative weight, this is 100, this is 150, this is 160 gram, then this is 200 gram, then this is 400 gram, then this is, अरुण थोड़ा पुराना देख लेना ना, पुराने में मैंने क्या किया, पूरी इसकी हिस्ट्री समझाई है कि ग्रेन साइज डिस्ट्रीब्यूशन पढ़ते क्यों हैं, कोर्स ग्रेन सॉइल के लिए इंपॉर्टेंट क्यों है, फाइन ग्रेन में तो वैसे भी फायदा नहीं है, पता चला कोहेजन के कारण दूर से देखा तो गंजे खेल रहे, तो कल वाली कहानी बताई थी, तो इसकी हिस्ट्री बताइए, वो बाद में देख लेना अरुण आप. 700, that is 800, that is 850, that is 865, that is 875, that is 900, that is 1000 gram of soil. Now out of 1000 gram, the percentage weight, 100 is how much percentage? 10%. How much 150 is? 15%, then 16%, okay, then 20%, then 40%, then 70%, then 80%, then 85%, then 86.5%, then 87.5%, then 90%, then 100%. Whatever the weight retained here, out since this we have put 1000 gram of soil, na? We have put here 1000 gram of soil. So out of 1000 gram of soil, different we here retain something, here retain something like this. So 100 is 10% of 1000, 150 is this. Now percentage final, how to do, please see. If 10% is this, I will tell you logically also. 90%, 85%, 84%, 80%, 60%, 30%, 20%, 15%, 13.5%, 12.5%, 10% and 0%. Now I am telling you logically also. See, everyone, every commando, if out of 1000 gram, if out of 1000 gram 100 is retained here, okay, if out of 1000 gram 100 is retained, then that means out of 1000 gram 100 is retained, that means 900 is going down, that means 900 is going down, okay. So 900 is going down, means 900 is fine, वो छोटा था, so 900 means 90%. I hope you got it. Out of 1000 gram 100 gram is retained, that means 900 gram is going down. Going down means smaller particle means 90% finer. Out above 50 gram is 50 gram is retained here, and above that 100 gram is already retained. So from this 20 mm sieve, 150 mm is bigger particle, because 100 तो ऊपर ही अटक गया था, 50 इस पे अटक गया, तो इससे छोटा तो नहीं है, तो 150 gram is bigger, that means 850 gram is smaller, finer. 850 gram means 85%, like this. Like this we get the chart. Okay, Arun. Like this we get the chart. Now from this chart, if we make a graph, everyone please see, we make a graph of percentage final and log diameter. Log diameter is generally write in a decreasing order, decreasing diameter here. Okay, like this. Now first of all, please see that why this is semi-log graph paper. This is the arithmetic scale, this is the log scale. See, percentage final will range from 0 to 100, but diameter is ranging 10,000 times. Yaar, see the diameter. If you see 80 mm and 75 micron, 75 micron, okay, there is a 10,000 variation. This 75 micron is 0.075 mm. 0.075 mm, 80 mm is a huge difference, more than 1000. So that huge difference cannot be accounted in an arithmetic scale. That huge difference cannot be accounted in the arithmetic scale. Okay, hello Rituraj. कैसे हैं सब चंडीगढ़ में? So that huge difference cannot be done here in this arithmetic scale. So for that log scale is used. Because see, if numbers are 1, 10, 100, 1000, a huge scale is required from variation from 1 to this. But if I convert this log base 10, this is 1, this is 2, this is 3. So a scale is shrinked. Okay. So, my friends, my commandos, my champions, everyone, this is an arithmetic scale because diameter has a huge range. Now, please see this, everyone. If I draw this percentage final and log diameter, if I draw this percentage final and log diameter, please see, then this is decreasing. The graph will be something like this. Reason also I am telling you. It is quite obvious that when the diameter is bigger, the percentage final will be more. Ishant Sharma is a tall cricketer. So percentage cricketers who are shorter than him will be more. Okay, so here the bigger diameter, then smaller, then smaller, then smaller. So bigger diameter has more percentage final. Then smaller diameter will be having less particles. More smaller particles will be having less percentage final. It is quite obvious. Okay, suppose here, what is our value? Suppose here, if I make a graph, this is log D, this is percentage final, and dia decreasing here. Okay, so graph will be something like this. Now see, D60. Okay, percentage final 60. D60 is 2 mm. So log 2 mm. Okay, now for 30%, diameter is 1 mm. 30, this is 1 mm, log 1 mm, like this. Okay, got it? Now from here we have D60. D60 means that diameter below which 60% particles are there. D30 means that diameter below which 30% particles are there. D10 is that diameter below which 10% particles are there. D10 is also called effective dia. D10 is also called as effective dia. And D50 is also called as average or mean dia. What is D32.5? That diameter below which 32.5% particles are there. What is D19? That diameter below which 19% particles are there. And it may be, मैंने तो ऐसी जादुई कैलकुलेशन ली थी कि D60, D30, D10 सब आ गया. Might be अगर एग्जामिनर को बहुत ही चैलेंजिंग क्वेश्चन बनाना हो, ES सब्जेक्टिव का 50 मार्क्स का क्वेश्चन, then here 60-30 term are not coming. Such data he may give. In such cases you have to do interpolation, but that question will not be coming in our syllabus. That much tough question will not be coming in our syllabus. Okay, but if it comes, then we have to do from interpolation. D60 is that diameter. It is not only that D60, D30 and D10 are there. every D is there. D 42.22 is also there. D 32.62792 is also there. Every D is there. Dx means that diameter below which x percentage particles are there. D60 means that diameter below which 60% particles are there. Now, please see here, I am telling you a very interesting thing. Shall I take a new slide? Shall I take a, okay, here. ओके अब सारा भाई यही है, इसी स्लाइड में सारा ज्ञान है. आज की क्लास का ऑल निचोड़ विल बी हियर इन दिस स्लाइड. ओके, प्लीज सी हियर. log D percentage finer. See, suppose my friends, one soil is this A, one soil is this is B soil, one soil is like this C soil, and one soil is this, that is D soil. Now let me tell you, A soil, first of all let me tell you A soil, whole class निचोड़ is in this slide. सारी क्लास का निचोड़ इसी स्लाइड में है. ओके, नाउ सी, A soil is well graded soil. ओके, लेट मी टेल यू यार, ये कितने फोन करते हैं भाई यार. वोडाफोन वाले का कितने इधर से उधर, उधर से इधर. ओके, सी, ब्लॉक कर दिया सबको. वेल ग्रेडेड सॉइल. सो वेल ग्रेडेड मीन्स द बिगर पार्टिकल्स आर ऑल्सो दियर. Okay, small particles are, average particles are also there, so that the voids can be filled. These all I am talking of, I already told you at the beginning of the class, this is all relevant for the coarse grain soil. For fine grain soil, even with large voids, it can be very strong with cohesion, and very small particles are also there. Big, small, average, all types of particles are there, so that voids can be filled. All types of particles are there. Okay, this is well graded because, why well graded? Because it contains particles of huge range, from big, small, big, double XL, XL, large, small, very small, every particle is range. It is a huge, more flat is the curve, more better it is. For coarse grain soil, more flat is the curve, more better it is. More flatter, more better, because it contains wide range of particles. Because it will be containing wide range of particles. So flatter the curve, better it is. Flatter the curve, better it is. Got it? Yes or no? Okay. Now B, A and B are similar type of soils. Similar gradation. Okay. Now what is next? That is C. C is uniformly graded soil. Uniformly graded soil means all particles are of same size. There are no smaller particles so that they can fill in the voids. There is no smaller particles so that they can fill in the voids, and that is also poorly graded soil. For coarse grain soil, they are very poor. I don't want that all particles are of same size. Otherwise, how the smaller particles will go in the voids? Okay. So, this is uniformly graded soil. Because see, flatter is the curve, better it is. For coarse grain soil, flatter the curve, better it is. See here, there is no particle here, no curve 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 here. All the curve are in this range. So that means all the soil is like this. Okay, this is the best curve. This is the worst curve. Yellow is the best, green is the worst. Now D is gap graded. D is gap graded soil. That means either the bigger particles are there. It means either the bigger particles are there or smaller particles are there. Little bit better than uniformly graded soil, because uniformly have even not that smaller particles. At least here some voids are filled, not as compacted at this, but at least some particles are filled. Okay, gap graded means, see, from this diameter, suppose 30% particles are finer. From this diameter also, almost 30% particles are finer. So this is gap. Okay, guys, if I say that in BYJU'S company, the teachers who are earning more than 2 lakhs per month are 30 teachers. And those who are earning more than 40 lakhs are also 30 teachers. That means there is no teacher who is earning from 30 lakhs to 40 lakhs. I am again saying, on yearly basis, if there are, I am taking different data, suppose there are 30 teachers, delete, I guess 32, 3, I have 10 का multiplication से कुछ गलती कर दी. Suppose there are 30 teachers who are having salary more than 2 lakh per month, and there are 40 teachers whose salary is more than 2 lakh 50,000. Leave. Sachin has made more than 50 runs in 20 matches and more than 100 runs in also 20 matches. That means he has never made run between 50 to 100. 50 से ज्यादा सचिन ने 20 बार मारे हैं और 100 से ज्यादा रन भी 20 बार मारे हैं. तो इसका बार भाई हर बार उसने 100 से ऊपर ही पहुंचाया, 50 और 100 के बीच में आउट नहीं हुआ है. That is the gap gradation. Flat portion represents the gap gradation. Okay. फिर इसमें और कहानी भी बन सकती है, कि आपके पास अगर ये कर्व है, ये 75 माइक्रोन की लक्ष्मण रेखा है, ये परसेंटेज फाइनर है, ये लॉग डायमीटर है, या बड़े पार्टिकल या छोटे पार्टिकल. अगर कोई ऐसा सॉइल है तो मेजरली उसमें कोर्स ग्रेन सॉइल है, और कोई ऐसा सॉइल है तो इट इज फाइन ग्रेन सॉइल. ओके, तो हम कहते हैं कि भाई जो पोजीशन है ना सॉइल की, तो वो पोजीशन जो कर्व की है वो बताएगा कि कोर्स है कि फाइन है, और जो शेप है वो ग्रेडेशन बताएगा कि वेल है कि पुअर है कि गैप है, वो ये बताएगा. तो पोजीशन ऑफ द कर्व बताएगा कि कोर्स है, उधर है तो फाइन है, इधर है तो कोर्स है, ज्यादा इधर है तो प्रीडोमिनेटली कोर्स है, और शेप उसकी बताएगा ग्रेडेशन. ठीक है, अब आगे चलते हैं. एक टर्म होता है कोफिशिएंट ऑफ यूनिफॉर्मिटी. देयर इज अ टर्म कॉल्ड कोफिशिएंट ऑफ यूनिफॉर्मिटी. सो कोफिशिएंट ऑफ यूनिफॉर्मिटी इज D60 by D10. D60 means diameter below which 60% particles are there. D10 means diameter below which 10% particles are there. CC is coefficient of curvature. So coefficient of curvature is D30 square divided by D60 into D10. Okay, D30 means diameter below which 30% particles are there. For a soil to be well graded, for a sand to be well graded, Cu should be greater than 6. ये 6 से बड़ा होना चाहिए, और also Cc should be between 1 to 3. For gravel to be well graded, Cu should be greater than 4. And means both. भाई and मतलब दोनों क्राइटेरिया फुल होने चाहिए तो वो वेल होगा. एक भी क्राइटेरिया फुल नहीं हुआ तो इट विल नॉट बी वेल. In that case, it can be poor or it can be gap, but it will not be well. For well, both criteria should be filled. These both criteria for sand, these both criteria for gravel. Can you tell me Cu for perfectly well graded soil, Cu value for perfectly well graded gravel? Can you tell me? Can you tell me? Tell me please. Okay, see, when it is perfectly uniform graded soil, that means all diameters are same, D60 and D10 are same. In that case, it will be 1. In that case, it will be 1. In that case, it will be 1. Got it? Now, let us do a question. Everyone, can you please give me this answer? Can you please give me this answer? CU and CC both are satisfied. Yes. Tell me. See, grain size is find out for coarse grain soil, it is done by sieve, but fine grain soil, that is done for pipette. Guys, what is pipette method? Hydrometer na in deepest detail. You can see in this channel my video. You can write Abhinav Negi pipette method and hydrometer method. सबको सीव एनालिसिस पता होता है. पिपेट और हाइड्रोमीटर मेथड का डीपेस्ट एनालिसिस मैंने इसी चैनल पे इसी अपनी वीडियो पे किया हुआ है, तो उसको देख लेना आप. ठीक है. तो फाइन ग्रेन फॉर coarse grain soil we do sieve, for fine grain soil we do pipette method. Why for fine grain soil? I have already told at the beginning, because fine grain soil make flocks, so sieve does not give the good result. Specific gravity can be find out from pycnometer. Permeability is from permeometer, and cohesion for soft clays which are sensitive has to be done in the field, because in lab their properties will be drastically changed. So soft clays are very dense, sensitive, so that for vein shear test. So it will be 4, 1, 2 and last is 3. 4, 1, 2, 3. 4, 1, 2, 3, that is A option. 4, 1, 2, 3, that is option number A. That is option number A. So let us do a numerical also. Try this. This is a previous year gate. This is a previous year question of gate. Please do this. Please do this. See. Okay, out of 500 gram soil, 600 micron है, एक 500 micron है. So dia here I am writing in micron. 600, 500, 600 micron sieve, 500, and then it is 425 micron sieve. Okay. फिर weight retained in gram, 200, 250 and 50 gram. So if I do cumulative weight, if I found cumulative weight, then cumulative weight is 200, 450 and 500. That I done beginning. Percentage cumulative weight. So 200 is out of 500 is, total is 500 na. So 200 is how much? 40%. 40%, 450 is 90%. And 500 is 100%. Okay. So this is 40%, this is 90%, this is 100%. Now percentage finer. This is 60%, this is 10%, this is 0%. Okay, what they have asked? CU. See, D60 here we got. I told you, in the exam they will be giving data like D60 will be obtained. That is 600 micron. Below is 60% particles are there. Below is 10% particles are there. This is 500 micron. Even if the data is such that 60 and 10 will not be coming, then in that case we will be having interpolation. So here it will be 1.2. That is D option. Everyone got it? Okay, yes, this is from PYQ. Nazim, I already written this यार, छुपा थोड़ी ना हूँ भाई. अब इसका क्लासिफिकेशन भी आता है. That is our next class. That is Saturday 6:30 p.m. Okay, Saturday 6:30 p.m. we'll be doing this. So you can join me. This is your homework. This is your homework. Please write down this in the comment section. If you want answer, you can join me in my Telegram group, Civil by Abhinav sir. So this is the startup series, guys. These are done. Now homework will be discussed here, and soil classification. One question was of soil classification. That is Saturday 6:30 p.m. Saturday 6:30 p.m. And tomorrow, Friday, tomorrow I am coming here, guys. Tomorrow I am coming here at what time? 7 p.m. 7 p.m. I am coming here. Okay, back interview guidance session at 7 p.m. tomorrow. I will be seeing you all there. Okay, and Sunday ka Funda, this Sunday it will be very special about Sunday ka Funda. Please do watch me there. Yes, you can take the scholarship. Scholarship test is there at 30th April at 12 p.m. on BYJU'S exam prep app. This test will be on our app. Please do register this. And 90% scholarship you can avail on the paid courses. Even if you don't want paid courses, you can give this test so that you can check your performance on the All India level free of cost. Okay. So thank you guys. See you tomorrow for the back interview guidance session. Thank you all. Thank you everybody. Take care. See you all. Thank you.